Yeah, as a cost-cutting measure, we combine samples, and I thought to myself, well, why? Like, I don't get it. Like, why does that make sense? So that's why the problem arose, because let's answer why it makes sense to combine samples. But first things first, you see what's going on. You basically have one vial that contains 5 different people. So as soon as all the blood goes into one vial, you have it's a soup of blood. And you can't then centrifuge it back out to figure out which blood is which person's. It's just one big soup. So sorry, is that gross? I'm sorry. Oh, I'm sorry. Sorry. No. So the
She has no voice.
oh, no voice. Oh, sorry too. I'll make up for you. How's that? On average, we'll be fine. So the idea is you might get a positive test result from the combined sample. And the problem with that is you have no idea how many of the people in that sample actually have Hep. It could be all of them. It could be 2 of them. It could be 1. It could be 4. It's not none. That's the only thing you know is it's not none. So I started with E1 and E2. What's the chance it comes back negative? And what's the chance it comes back positive? So let's start with that. First of all, let's start with this. How do you know it's binomial? Other than the fact that it's the homework for the binomial.
Either they have it or not.
Good. There's number 1. It's a mutually exclusive situation of 2. You either have Hep C or you don't have Hep C. Nice. What else makes it binomial?
The numbers we got, like 4 now. We know.
Oh, good. You have a constant probability. Good. Oh, good, Elena. This is good, actually. Then you have to look at it from an independent point of view. If you've selected 5 people, you're assuming the percentage is not changing because there are so many people that are in the pool. Like the chickens. Max pulls 4 chickens out of thousands. So you're not changing the percentages. Good. And one last thing that's important.
So it's independent variable.
Independent, which is 4.1. 2 mutually exclusive outcomes. And one last little bit. I'll give you a hint.
There's 5.
Right. We're not going to keep selecting people until we get Hep C. We're going to go out and say, I'm going to grab 5. So it's a fixed number of trials. That's the other key part. Elena, you got the important parts, which is the independence and the bi and the binomial. But you also can't keep selecting until you get a desired result. What makes it binomial is you stop. You start, collect, stop. Binomial. Fair enough? Good. And that helps us keeps the probabilities consistent. Okay, so we know it's binomial. The first question I have is, what's the chance the combined sample comes back negative? Well, let's think about this distribution. Let me mute this. Let's think about this distribution for a sec, shall we? This is E1 binomial. Okay. Let's think about this distribution. Is it discrete or continuous? If we're talking about number of people, either have it or don't. Number of people that have Hep. Is it discrete or continuous? It's got to be discrete because it's the number of people. 0 do, 1 do, 5 do, 4. It's a number. It's a countable number, correct? So we're going to make that our x column. This is the number of folks with Hep C. Okay. And over here we're going to have probabilities. So this is chickens. Having Hep C, not having Hep C. Getting a rooster, not getting a rooster. All you got to do is adjust the probabilities accordingly. Is that fair enough?
In fact, it could be either 0 or all 5.
It doesn't matter, but usually by convention, it starts with 0 and counts up. Everybody seeing why it goes from 0 to 5 there? It's got to go 0 to 5 because if you have 5 people, at least 0 are going to have Hep, which means the least number you can have is nobody. And since the rate of Hep is so small, that's going to be the most common outcome. And the most of 5 that can have Hep is all 5 of them. Good. Now how do you generate these right here? Yeah. You have 2 choices. You can run the formula that I never showed you, which I encourage you not to do, or you can use the program that I happily gave you to get the... Yeah, exactly.
So,
Go ahead, Haley.
the probability
Yes, ma'am.
is going to be what it just gave us, the 4.1% or no?
Yes, exactly, because that's the chance of Hep C infection on one person.
Okay.
And we've got to check it, and this is where it comes. Haley brings up a good point that 4.1% is a huge part of this problem. That's the rate of infection for one person, a Hep C in one person. We have to then keep track of all the 4.1% and therefore the 95.9%, which are the chance of not having Hep C in one person, but we've got to do the Marge, Bertha, Nancy, Mary thing, which who has it, who does it. Remember we were doing that in class? Oh, she does, she doesn't, she does, she doesn't. That gets very old very quickly. And that's where the program comes in. I made you do those chicken distributions for 2 hours that day. And then you had enough. You did. And that's exactly why we started doing it this way. All right, so let's fire up the machine. FYI, if anybody needs the programs during the exam, I'll have my cable with me. I can share them with you. Don't sit there and try to fix a broken program. Just let me fix it for you, okay? All right, here we go. Disk fill. Number 7. Run it. Smallest X.
0.
Yes, ma'am. Largest X.
5.
There you go. Fill by binomial. Probability, make sure you put it in right.
0.041.
Make sure you get the 0 in there. Make sure it's not 41%. That's slightly more prevalent. 0.041. It's going to say done, which is not very helpful, except for everything you now need is in your stat lists. Everything you need is in that stat list. So when you go over stat, edit, there they are. You can ignore L3. You don't need L3. That was from some other class I was running, I guess. There's all the numbers you need. There's an 81% chance that no one in the sample is going to have HEP.
So just go out like 2 decimals?
Ish. Yeah. Two's fine. Two's fine. There's an 81% chance that no one has HEP in the sample. There's a 17% chance that one of them has HEP. There's about a 1.5% chance that 2 of them have HEP. And now look how small it gets. Now, hopefully this makes sense. Hopefully this makes sense. With a rate as small as 4.1%, you shouldn't be having all 5 of them coming down with HEP. Out of 5. I mean, it should be almost 0 as far as the chance goes. You should see the vast majority of the time not getting any infection of HEP. Does that make sense? So I'm just going to, in this part of I'm just going to put C distill. How's that sound? Distill. A lot of traditional stat classes, what they want you to do is to get in there. What's the chance that at least 2 but no more than 4 have HEP? And questions like that, which are all fine. They're fine. But they're missing the big point. The big point is that there's almost there's about an 80% chance that the test is going to come back clean. Now, why is that good? What does that tell you about those 5 people? They're all clean. So what you just did was you did one test that cleared 5 people.
So that's why they do it together, because it's such a high chance of not having it?
Boom! Yes,
so
Jada.
if it did come back positive, then they would...
And we're going to get to that, friend. And we're going to get to that. That's the next, that's E2 and E3.
Okay.
And Jada's question is amazing, because what it does is, and this is why I took your out-of-class part of your exam, is to, okay, how many should we group at a time to minimize the cost of testing, but still get the people identified that have it?
Yeah.
It's a great, great question, and that's why I want to start it today, and you'll finish it for your take-home. Good. So, the answer to E1, what's the chance the test comes back negative? We just figured it out, didn't we?
81%.
There's the chance the test comes back negative right there. Perfect. So, E1 is 81%.
19.
And the next question is, what's the chance it comes back positive? Well, resist the urge to say it's 17.3. It's all of these. Every single one of these is going to result in a positive test result. There are actually 32 different configurations of have or don't have Hep C. And they're all accounted for in this distribution. That's why this program is so wonderful. All those goofy Marge, not Mary, Nancy, not Bertha. All that is accounted for in this program. Only one of the configurations is everybody's clean. The other 31 are accounted for right here. It's totally rad what's hidden right there in this distribution. So yeah, the chance of not having Hep C is whatever left, or excuse me, the chance of a positive test result is whatever's left. And whatever's left is the other 19%. Because think about it, when they take that vial and they test it for Hep C, the vial is either going to come back positive or negative, right? If it comes back negative 81% of the time, it has to come back positive the other 19-ish. Fair? Mm-hmm. Now, of course, your project also taught you to be skeptical about false positives and false negatives. Good, and we'll talk more about that in 244, which is a huge chunk of 244 as well. Yay, last project. I didn't realize that. You guys started your last project today. Hell yeah. Hell yeah. How's that feel?
Great.
Yeah? Did you learn something useful in there? Did I tell you the story about my student that came in and said her aunt had gotten diagnosed with breast cancer? And she sat down with her and ran the math, and it turns out she was a false positive too?
Really?
I mean, it's staggering. It's staggering how the medical community doesn't necessarily understand this stuff. There's an entire book written, Random Walk, great book. I haven't read enough of it yet, but quite a bit of it is talking about the medical community and the misunderstanding of positive test results. The chance that just because it says positive does not mean, the guy that wrote the book tested positive for AIDS, and it was a false positive. And that's what kind of spurred him to write a big chunk of the book, was the interpretation of those test results and knowing. Now sometimes positives are correct,
Yeah.
true positives, but the false positive rate, you can't ignore them. I mean, you can ignore it here because I'm not asking you to analyze false positives in here, but anyway, pause, unpause, back to here. Cool. So now the question is, this is E3, which is probably my favorite question of the batch. Let's switch back over to here. Here we go. A Hep C test. Go ahead and read that little bit right there. I gotta get some more. Oh, gotta get some more ink in this marker.